So task is the major thing in gearbox. Do you know the tag one is psychology? Definitely, you know this. Why? Because of EGC. It is there now. Engineering graphics. EG. Engineering drawing. Sorry. Engineering drawing is there. In that CAM profile you have drawn some unwinding the thread, something then narrator. That. So this is involute profile. This is psychological profile. This is also based on application. Why means involute profiles it will be used in major application. 98% of years will be manufactured through. Daily it is rotating continuously. So each day, if it is rotating with the efficiency loss of 1%, think about the 30. So in that kind of high precision accuracy application, this cycler profile will be used. Am I right? So nomenclature. You may see this also. Anyone please? Huh? Can you say something about nomenclature? What you understood from institute? Anyone? Right or wrong? Not an
From the center of the gear to the top line of the seat, that is the addendum circle, and to the baseline, that is the addendum circle. To the center of the seat, that is the circular pitch. We can say circular pitch of the gear, or the top side of the seat, that is known as the top head, or from the circular pitch, the bottom part is known as the flange, and the upper part is known as its neck. Space between two successive seats, that is known as the circular pitch, or the space between two seats, that is known as the width of.
exactly. Actually, this nomenclature is the heart of gears. So you can't hesitate or you can't avoid anything about this nomenclature. See what is it? Top line. This is top line. This is circular pitch or pitch is circle diameter we used to say. So below, this is dedendum, this is addendum. Addendum and dedendum, it will be segregated with this pitch line. So the space which is above pitch line will be space which is below pitch line will be considered as dedendum. So these are all the gear nomenclature. So wherever you are studying about gear, you need to correlate with this nomenclature. That's why even in academic also this will be in the stage. So okay, forget about the gear. Focus on the teeth. What a teeth says. What a teeth says. How we can calculate a teeth. How we can assume or how we can consider a teeth. So engineering it is an assumption. Engineering is also like a horoscope. So you are assuming something, you are predicting something. So how we can assume a teeth? Anyone? Right or wrong? No matter. Sorry? No. I'm asking about the load factor. Beams you may see, no? Beam. Cantilever, anti supporter, fixed. So in which beam concept it will? Can I use chart please? Chart. Can you print something? Which beam it will cause? One. Next. I'm expecting something from the last. Please. Always last can be easily caused. Last, please. This is cantilever. Method. Area of gear. Why means it will not engage fully. It will not engage in the tip also. So it is going to be. This is the major thing. So here the PCD and the opposite base pair it will play a major role. Okay, so this is the active contact area. This is the technical term what we use in gears. Active contact area. Based on active contact area only, gear efficiency can be calculated. You can write it. I think now everyone will not an issue. Close your mouth. Just to make you somewhat chill. Okay. So this is the anyone feeling sleepy? Say yes or no. It's not looking like mechanical. Say yes or no. I'm also from mechanical. This is looking like easy or triple E. Be like a mechanic. Last bench again. Okay. So any doubts in nomenclature? Have you seen this kind of parameter anywhere in this institute? This expression. Can you see the here? Why it is formed like this? It can be in the rectangle manner. We can design in rectangle now. Here are like this. Yes, no? We can design this in this manner also. No? Why it is not designed like that? Again, failure if you are designing will be. That's why this pressure angle is used. So there are lots of pressure angles like 14.5, 20, 22, 25, 30, even 30 also there. This is what I said is standard pressure angle. In automobile industry, they are using 14.5, 22 also. Based on the application, load carrying factors, based on the failure, based on efficiency, pressure angle, it will vary. So pressure angle, it is not having any thumb rule that it need to be like this. Pressure, if you vary the pressure angle, you need to invest your money in cutters. Amit, he is my senior, so he will detail explain about the manufacturing process. In that you will see the cutter process. Okay? So it will increase, if you change your pressure angle, it will increase your investment on cutter. So cutter, just predict something like how much the cutter cost will be. Tentatively, 2 crores, 5 crores, something, 50 rupees, 10 rupees, something. Each cutter will cost around 6 to 7 lakhs. For each module, you need to buy a separate cutter. Cutter, it is having depreciation. Have you heard the term depreciation? Like that. So each material it is having depreciation. If you invest in a cutter, 6 lakh or 7 lakh, it can be used just only for 2 to 3 years. After that, you need to scrap it. Again, you need to invest 6 to 7 lakh. So that's why instead of investing on cutters, we are playing with the design. Can you understand any doubts? Okay. So if we vary pressure angle, what it will happen? Do you know law of gearing? Law of gearing. Have you heard anywhere? Kinematics, dynamics. In your syllabus, whether you are having kinematics and dynamics? Little bit louder. Okay, not an issue. See, based on law of gearing only, gears can be designed. Omega, what omega means? Angular velocity. So omega 1 should be equal to the omega 2. So if you see this pressure angle, nomenclature, say opposite gear will be made up here. What is this? Gear machine. So this is 1, this is 2. So this law of gearing is nothing but if you draw a tangent line of PCDs of gear wheel and gear pinion. This is pitch point, TP. Pitch point. In pitch circle, where the gear is getting engaged, that will be considered as the pitch point. From that pitch point, loading area can be calculated. Okay, this is pitch point. So this is law of gearing. Omega 1 into P equal to omega 2. If it is not equal, means what it will happen? So you know about addition. Definitely you might know. What is addition? Okay. Right formula. 1 mark. Fundamental.
How much output we are getting?
Then what about loss? What is meant by loss? Loss. LOS. Due to friction, loss it will occur. Loss it will come. Then how you can calculate the loss? Delta. The variation. You have thermodynamics, no? Thermal 1. What is thermal first law? Again. Thermal first law. First law of thermodynamics. Louder, anyone. First law of thermodynamics. Yeah, exactly. Zeroth law. No, forgettable. Because of first law, thermodynamics law, it is not going to influence you. I'm asking for the funda. Because of I can correlate it. So what is zeroth law of thermodynamics? Energy can be exactly. So what is thermodynamics first law? It is saying that first zeroth law it is doomed. It is a failure law. Why? Because of energy cannot be created nor be destroyed, it can be transferred. So in thermodynamics first law also to sometimes it is there. What do you know? Kelvin Planck statement? Yeah. What is that? So Kelvin Planck uses what is passive statement?
Energy cannot move from lower to higher without any external.
Exactly. Without any external substance, you can't transfer energy. So first law what it is saying, energy can be transferred into work. So Kelvin Planck what he is saying, energy can be transferred without any, the energy cannot be transferred without any loss. What passive he is saying, energy can be transmitted, loss will be there, but that energy will be transmitted with some additional, that for the software, that for the support, some agent is there. So this gearbox are the agents. So if you see the efficiency of this agent, again input, output, the variation between input and output is considered to be loss. If it is in positive sign, that is profit, higher efficiency. If it is in negative sign, it will be considered as a loss. So if omega 1 and omega 2 is not equal means loss will be failure. So failures it may occur. Why? Because of, say, for example, if pinion is rotating in one axis, wheel it is rotating in some other, what it will happen? You can't predict that. Destruction, blast. That's it. Have you heard this macro geometry and micro geometry? Even in industry also, still this is in research. So have you heard anything about macro and micro geometry? Say something about that.
Micro means small and macro means large. Micro is related to its item and macro means overall study or something.
Yeah, observation is exactly right. What are all the parameters of gear? Do you know what is parameter? The term parameter. What is it? Damn parameter. How you can denote a bench? How length it is? How much the height is? How the weight is? That factors will be considered as a parameter. Do you know what are the parameters which is going to involve in gears? Parameter. Already we see. Yeah, that is the parameters. Major parameters will fall under macro geometry. Minor parameters will fall under micro geometry. See, this is the loading area. This will be considered as contact area. Active contact area of gear. So, this is nothing but while designing the gear, we need to consider total contact ratio. What is the total contact ratio? This area is going to be considered as the contact ratio. For single tool, I am saying. For single tool, this is the total contact area. How we can calculate total contact area? Reading something. How we can? Wheel it is there, pinion it is here. Yes, no? This is PC. Can you understand now? So this area will be intercontact. Yes, no? So here, the active contact length of wheel by the active contact length of pinion is contact ratio of a tool. Yes, no? The ratio is nothing but the active contact length of wheel by pinion. So this is the active contact ratio of one tool. One tool. How we can calculate for a gear? Exactly right. Do you know about why we are using per helical bevel something? Why we are changing that?
Because we have different load carrying capacity.
Exactly. See, parallel it is not having any angles. There's no angle will be in zero condition. Helical it is having some helix angle. There's no. If you tilt that, the contact area can be increased. So comparing the difference between spur and helical, if you compare both gears, helical gears it is having much more load carrying capacity than spur gears. Can you understand? So, what in spur, how many tools it will be in? Just imagine. How many tools it will be in contact? One. No, actually one. One it will be in fully contact, one it will be in partially contact, next it will be in partially removing condition. Yes, no? Because of two, if you imagine that, one it will be in fully contact, one it will be in partially removing condition, one it will be in partially engaging condition. The same thing, compare that with helical gears, what it will be. But the contact ratio it will be little bit higher. So if you see, generally if you say it in a round figure, 3 it will be in contact for helical gears. But 1 is in full contact, 2 is in partial contact. Yes, no? This full tooth gear is also not fully getting contacted. Why? Why? Because of this is the active contact length. Yes, no? So just 60% it is getting contact in a single tube. Then what about the two? Just 40%. Partially getting contact and partially getting removed. So 40 plus 40. Totally how much it is? 0.4, 0.6, 0.4. 60%, 40%, 40%. What is the contact ratio? 1.4. 140 times. Yes, no? In spur it is 1. In helical it is 1.4. 100, 140. This is why helical gear it is carrying higher load than spur gear. This is the comparison between spur and helical. So, how it can be defined? Total contact ratio is nothing but the transverse contact ratio plus overlap ratio. Transverse contact ratio is nothing but, see, this is the phase, gear phase. This is the center axis. For it will be tooth, it will be 0. 0. Yes, no? Helical it will have some angle like this. So this contact area, the entire flank contact, that will be considered as transverse contact ratio. Everyone can catch me now? If you have any doubts, just hold me there. So this is transverse contact. Then overlap ratio. What is overlap? See, here also the flank is getting contact. Here also the flank is getting contact. Yes, no? How it is increasing the contact? For spur and helical. It is having some angle alignment. Spur it is in 90 degrees. Helical it is in some tilt. So that tilt it is increasing your contact. So that tilt is considered as overlap. So transverse contact ratio plus overlap ratio is total contact ratio. Can you get my point? So in spur, overlap ratio will be 0. So total contact ratio is transverse contact ratio. In helical, it will have some values. So whether any gearbox can be designed only with the support of gears? Yes or no? Gears it is there. Gear is just a component. So what about gearbox? Everyone you are having it. What are all the subcomponents that is related to gear?
Great types of gear
Bearing. Next. Barrel, shaft. Gears also is having pinion, gear wheel. Pinion, gear wheel. Wheel it is just the gear part is will be considered as the wheel. So shaft is gear will be considered as pinion. So pinion, wheel, barrel, circlets, oil field, fastener, distance piece, spaces we used to say. Why? Pinion it will be, gear will be, it will move slightly. At that time we need to arrest that movement. So we are using some dummy component. That dummy component will be called as DP, distance piece. Or else directly you can say it as a spacer. You are arresting the space, so it is called as a spacer. So all other components will be less than gears or gearbox. So gearbox industry. What is gearbox? Gearbox or industry? These are all without all components will be less as the gear. Unlike industry is having lots of subdivision, department, branch. Industry is not only with the machine, production unit, manufacturing production, both are there, designing it is there, planning, industrial engineers there, What are other departments it will use? Other departments in industry. Yes. You are in final year. This question it will increase your grade. What are all the departments that is there in industry? Sales and marketing.
Quality department.
Quality.
Inspection. Store.
Then next. Testing. Exactly. Next. Purchase. So, logistics. So, it is not like we are in mechanical. We need to go for machine operation. Lots of other few departments is there. We can focus on other few departments. Okay. So, what is the difference between QC and QA?
QC is quality checking.
What is the abbreviation of QC? QC.
Quality control.
But QA. What is the difference between QC and QA? Whether both of them are equal? Quality control is nothing but just assume you are a designer. Okay? Who you are? Hey, we are electrons. Suddenly we need to throw our answers. Who we are? For example, designer. Okay? You will give some dimension. Quality control team, they will check whether this dimension is achieved or not. That is quality control. You are controlling the quality. Quality assurance here. If it is not controlled, if some deviations it is there, they will give some protective or preventive action. They will take some preventive action. They will correct that. They will form a SOP, standard operating procedure. So that it will stop the issue in future. That is quality assurance. This is the difference between quality control and quality assurance. Okay, clear?
Yeah.
So what design team do? Forget about what design team do because the answer is no. Yeah. Why designing? What are the considerations we need to take? First is material selection. Without any material, you can't design anything, you can't manufacture anything. Material selection. How materials can be selected? What are the types of materials? Types of materials. Types of materials.
Steel.
Ferrous, non ferrous. Ferrous, non ferrous. Yeah. So, generally, have you heard the term of case hardened through hardened? Case hardened material through hardened material. What is meant by DHL? DHL. HRC. DHL. DHN. DHN. Exactly. What is meant by HRC? HRC. Exactly. So, based on these two values, the material will be considered as through hardened or case hardened. Okay? Clear? Any doubts? What is meant by HRC or BHL? BHL denotes Brenner volume. What is meant by N? N. Staff they may carry you to some laboratory. You will be doing some impeaching this. Okay. Yes, no? Which semester? Last semester. Ball they will be using. That is known as indenter. Indenter. That indenter it is having many types. 13 to 16 indenter it is there as per ISY. So each indenter will be named as A, B, C, D, E, F, G, H. So this BHN is nothing but Fresnel harness or while using this indenter. Fresnel harness while using this indenter. Diamond indenter, ball internal, spherical internal, lots of agendas it is there. A, B, C, D, E, F, G, H. Like 13 or 16 agendas it is there. Based on that agenda, corners will be given. Any doubts? So this is material selection. Next, what R&D is? What is engineering? Some answers from that. Someone there say something. What is engineering?
Engineering.
You said lots of departments it is quality, concept. What is engineering?
It's science and mathematics.
Branch of the science which deal
The fellow who is dealing with the calculation, like this calculation. Yes or no?
Yeah.
Yes. So in engineering we are creating drawings. Engineers are just the drawing creators. In design, what are the subdivisions it is given? Nowhere it will be drafting. When you are completing a degree or diploma, you are going into industry. You are going to see the in design department as a trade. You will be considered as a draftsman. Next to draftsman is engineer. Next to engineer is draftsman design. Next to designer is engineer. Next to engineer is developer. Next to developer is researcher. So each is having his own portfolio. So draftsman, what he will do, the designer he will give the design. He will mark the parameters, length, distance, diameter, this. What engineer designer he will do? He will design what engineer he will do. What engineer he will do? He will design as per the manufacturing feasibility. We can't do anything. There is some limitation, there is some boundary. Based on that only we can design. That will be considered in engineering. This is the subcategory. Based on the portfolio, this will be reviewed. Material selection, everything will be. These are all the gear manufacturing process. This will be handled by my senior Amit. So he is expertise in manufacturing process because of he is more than 9 years. He is having more than 9 years of experience. You will be deeply leveraging or deeply expertise.
Manufacturing process basically this is related to single pinion or the wheel that we already discussed in this slide. Okay. So for any product we require material. Material should be in form of the round bar or should be in the coarse bar. Round bar should be available in specific sizes that we can use in our manufacturing. If some sizes are not available, then we go for the coarse size. So based on that, we can make our product. So first part is the rough turning. If we have the raw material with the round part, and we start to manufacture the pinion. So first process is the rough cutting. That will shape that particular shape which our required. It should be considered some allowances on that related to heat treatment and the distortions. You can see in this image that the round bar is placed and this is the base cutting is there. After rough manufacturing, then we go for the hobbing. Hobbing is nothing but the tooth cutting of the gear. So in this case, we require particular cutter based on the size. The size can be defined based on the model. Any gearbox have the specific size based on that model. Based on model, we can specify the capacity of the gearbox. Okay, so whatever the given the details. So based on that, industrial engineering make a pre-program for the CNC machines, and that will be fit to the machine. So hobbing is the one type of the tool that can be used for the cutting the tool. You can find that there is different sizes of the cutter that is related to model. After hobbing, we need to go for the heat treatment of this pinion or the pin. So, why the treatment is required? Basically, there are the true hardened material and the case hardened material. Two materials are there. If the loading is not high, then speed is not very high. So in that case, we can use soft material for our transmission. But we require the higher load capacity, then we have to go for the case hardening of the material. In case hardening, we have just hardened the tooth area. Means in the tooth area which is come in the contact, that should be hardened with a particular depth. That is related to module as well as the application. How much case depth we have to require. The reason that the heat treatment cycle should be considered. So if we require some particular depth in X, so related to that time should be considered in Y. So if the X value is increasing, parallel Y value is increasing in the heat treatment process. So why heat treatment is required? Why we go for the case hardening rather than going for the true hardening? Basically, true hardening, if we go for the true hardening, so what happens? The material becomes brittle. So the strength of should be failure should be early. As well as if we go for the case hardening, the material becomes softer in the core. So it will get the higher ductility. It can take the higher stress level. So that's why we require to heat treatment for the case hardening. After heat treatment, there is some chances of the distortion of the material. If there is a long shaft is there, it can be bent, slide due to heating. So that should be straightened and then finalize the final finish form. So that should be considered in the finish turning. So this portion is related to the without the we don't consider the tooth area. What tooth area we require to go with the grinding operation. So grinding is why required. If we can do the directly machining and we can apply this pinion application, we can do that. But why we require to go for the grinding? Basically, we can consider that it is to smoothen the surface. When the surface roughness is high, it can they can say the high accurate gear is generated, and that will impact in our operation. It can smoothen the operations, it can reduce the vibrations, we can get the good contact. So this all parameter we can maintain in the grinding operation. So during heat treatment, we have already considered some allowances on that. If we consider the tooth thickness is the 8 mm. So during the machining, we have to considering the tooth thickness 8.6 or 8.8. That can be finalized at the time of the grinding operation. In grinding operation, there are the different accuracy classes there. That can be defined by the accuracy of the pinions or the wheel. In low speed application, we can consider the normally 6 to 7 class as per the team. Whenever we go for the high speed application, turbine, gearbox and gear, that we require the higher accuracy class. So in that case, we have to go for 4 accuracy class. Okay. So based on the accuracy classes, we require the high efficiency machine. Not every industry we can say that they can manufacture class 2 or the class 4 accuracy gearbox. Gear assembly. It is nothing but the whatever the design release the bill of material. Now what is the bill of material? Bill of material is a bunch of the components that is designed decided to manufacture or the assembly. So in that case there should be the pinion, gear, shaft, bearing, oil seal, covers, gear case, fasteners. So these are the components are including in the bill of material. And that should be the one unit, that is assembly unit, and that will be assembled. So in this case you can say that the how many stage gearbox is there? Anyone? Do you know the stage word of the stage means single path reduction. Okay, so here you can say that the first is the bevel path reduction. Second one is the helical. Third one is the again helical. Fourth one is the again helical. So it is fourth stage gearbox. And any gearbox size is depend on the large final center distance. Means last center distance size we consider as the size of thrust bearing, that is for the only vertical applications we have considered in the thrust bearing. Now, what is axial plane and radial plane? Radial plane is already defined in particular bearings. We can consider the ball bearing, cylindrical bearing, spherical bearing. But in taper roller bearing, there is no any value is given in the any catalog of bearing manufacturer. So that can be we have to maintain our in assembly. Basically, if we consider the spherical bearing, ball bearing, they have clearance detail is given already. So we doesn't require to change in that. But in taper roller, there is a two part is fitted at the time of the assembly. If we preloading that, then it will be generating the temperature issue. So that should be controlled during the assembly. So what is the axial plane we have to maintain during the assembly. Assembly means if we consider here that this is a taper roller bearing. So if we two cover is below is the two covers, we fitted together only, then the bearing, taper roller bearing comes in contact with the fully contact. So if there is some clearance between that, then it should be good for the application. So that can be particular value based on that the loading distance and all the things. Then inspection of the profile. Basically it is used for the any very special case only, and the profile is measured on the tooth and it can generate one graph. That graph is related to already we have decimal, that should be matched with that. If it is not matched properly. Another thing is that if matching component are we are making first time, so we have to check the profile of the both the tooth, and that should be matched. So this will help us to good contact as well as the backlash maintenance. So what is the advancement is doing nowadays in gear industry? So it is only we can say that is continuous process for the advancement. So manufacturing using the additive manufacturing technologies, we have to cover the very accurate manufacturing process that we have considered. Then we have to cover the powder metallurgy. Basically, powder metallurgy applicable for the small components and low load category. If we consider any composite plastic type gears, then that type of the product we can use. But we also use in particular metal. But it is in this case we require the same type of the gear in the mass production. Then developing composite materials, that is the one ongoing, so we can consider in the advancement. Then optimize with referring the dynamic behavior. Dynamic behavior means some of the application is not continuously taking same type of the load in same cycle. It should be variable. In some cases, so based on that we can optimize our design. If we directly define that in 1 minute peak load is goes to the for the 10-second only, and we consider the 60 seconds for the flow for our design, then it should be design should be higher, safer, and it should be costly. So in that case, we have to consider the particular behavior of the cycle, and based on that we can optimize the selection. And implementation of IoT, that is related to the monitoring of the gearbox, that is applicable to industrial where remote area cannot really continuously watch on that. That should be controlled by the system control unit. So that's the only from today. Any questions from?
Sir, IoT company.
Internet of Things.
Sir, no question.
Sir, this question is not related to this gear is all this. But suppose any student want to join this Elecon, which is the main product that is gear. So what type of job profile for them? Diploma.
So it's many departments in this. Many departments in this. In design, it is difficult to go the diploma because of every company they won't hire diploma candidate for design. So production it is there, production they will hire diploma students. Purchase it is there, they can hire. Marketing, production, purchase, SCM it is there. Lots of departments it is there. In that kind of departments we can go. Any doubts? Academics or person wise or company wise, placement wise, interview wise. This is mechanical, you need to shout.
No doubt, sir, whatever the query will generate, but for that requires some basic knowledge related to this. And they are in, I think, in 6th semester, so in 6th semester they are working across this our year related to. So, no doubt, whatever you try, that is base for them and also for us. But yeah, whatever is then that's such a potential for the question answer, that is the result for them. No doubt, I am not telling for feedback for you right now because I know your condition. So, in what of science, I thank both our experts for giving the much detailed information related to gears, which is helpful in your sixth sem in some subjects. And also, I am thankful to our Vice Chancellor, also our principal and HOD, so that we can arrange this our seminar related to our energy conservation and also for the gear meeting. And
most, no doubt, you have to give a big hand for that person, Ashok Nagum sir. He has tried a lot.
Not required things. I am working for 4 students. We have a total 8 sessions today in our polytechnic. Only you have 2 sessions, but other 7 sessions for the other departments. So specialty training and placement are organized with each department with collaboration with we have all experts from the specific areas. They have delivered their knowledge to the student. So I especially thanks to Amit sir and Krishna sir. So within 3 days they will reply and we will our team member they will join your celebration. Because today we are celebrating Engineers Day. Tomorrow we have holiday, but we are going to visit at Anand Elecon Company. So we have so many demonstration and other expert lectures or maybe any other activities there, and also the plant visit is there. So within 3 to 4 days, Elecon team have given the support. Immediately they have replied that our team member will join you. So I will thanks to the Amit sir, then the Krishna sir and Janki ma'am. I am coordinating Janki ma'am, which I am coordinating with all this activity. Thank you sir. Thank you very much.
Not last but least, I am also thankful to you because for 2 sessions and without making any noise and any mischief, you are listening both our session. Thank you for that. I know you are one more thing, you have to just fill up your online feedback. And based on that, each certificate will be provided to you. So online feedback is compulsory. Okay?